Okay, let's look at the fundamental theorem of calculus. This is probably the most important theorem of calculus, right? So this gives us a way to evaluate the definite integral, right? So definite integral from a to b of f of x dx is equal to f is any antiderivative of f of x. So capital F of b minus capital F of a, right? So you plug in the upper limit first minus plug in the lower limit, right? That's kind of how it goes. All right, let's look at a couple of examples. All right, so we have let's say definite integral from 1 to 2, 2x plus e to the x minus 4 over x dx. Right, so what you do is first I'm gonna put a square bracket and then write down the antiderivative. So antiderivative of 2x is x squared, right? Antiderivative of e to the x is still e to the x, right? So it's negative 4 is just a constant multiple, and the antiderivative of 1 over x is natural log of absolute value of x, right? Then you write down the lower limit as 1, so x goes from 1 to 2. Right, so next step is just plug in the top number first. So we're going to plug in, right? Plug in 2, so 2 squared is 4, right? Plus plug in 2, so you have a e squared, right? Minus 4 times natural log of 2, right? Then minus, then you plug in the bottom number. So 1 squared is 1, right? E to the first power is just e, right? Then you have negative 4 natural log of 1, so negative 4 natural log of 1, right? But you can see that the natural log of 1 is 0, right? Then we can simplify a bit. So this is going to be equal to, right? Combining, let's see, we have 4 here and a minus 1. So you're going to get 3, right? Plus, there's e squared right here. So you have e squared. And there is e here. So we put the that's a minus e actually, yeah, because of the negative sign here. All right, and this term is 0, so I'm just gonna forget about that. Then you just have negative 4 natural log of 2, which is this guy. All right, so that'll be everything. So you have that. All right, so that's the answer for the first example. All right. And the second example, here's a definite integral involving the substitution. Right, let's use a substitution. Right, in this case, you have a natural log of x, and usually u is going to be natural log of x. Right, then you go through the usual drill. Take the derivative of u with respect to x. It's going to be 1 over x. Right, and then take the reciprocal of both sides. You have dx over du is equal to x. Then we can just multiply both sides by du, right? So dx is equal to x times du. All right. Alright, then one more thing we need to do is since you have a lower limit and the upper limit, that we have to convert these are x values. So these are x equals 1 and this is x equals e. So we need to convert it to a corresponding u value. So x goes from 1 to e, right? So u is gonna go from, right, you just have to plug it into the substitution equation. U is equal to natural log of 1. Natural log of 1 is 0, right? Then when x is e, natural log of e is 1, right? So the integral, the new integral is going to go from 0 to 1. So those are corresponding u value. All right, then bottom x, I'll keep it because I'll be able to cancel it later. And then we decided to call natural log of x u. So we have a u on top. Then dx, we just found out that it's a x times du. Right? So we can cancel x and x, and to clean it up, you will get the integral from 0 to 1 of u du. Alright? Then we can take the antiderivative. So antiderivative u is u squared over 2. Then you are going from 0 to 1. And this is going to be, so plugging 1 squared over 2 is 1/2 minus plugging 0. So that's 0. So answer is positive 1/2. Alright, that's it. I hope that this was clear.